In our previous lecture, we were talking about these alternatives actually. So in cash flow calculations, there are a number of scenarios that we may face. These are the most common scenarios. Of course, there will be some others, maybe unrelated to these ones, but these are the most important ones. And once you know how to calculate the present, future, or annual words based on these scenarios, you will be able to calculate all others. Okay, this is the basis of understanding. Okay, what are the alternatives? We may be given a present amount of money and we are asked for a future value, okay? The present amount, and by the way, the present amount need not be at time 0. We call it at present as present, but look, if this is 0 and if this is, for example, time 8, then we use this factor. We want to find F, given P, interest rate is 10, and there are 8 periods. But if this is 10 and this is 18, okay, not 0 and 8, but 10 and 18, we use exactly the same factor. Okay, so it doesn't depend on, it shouldn't, I mean, the present value need not be at time 0, and it can start at any time. The only important thing here is the number of periods between the start and end is represented by this n. So this 8 is the number of years between the present value and the future value. Okay, 0 and 8, so there are 8 years. So this calculation, when P is given, we want to calculate F, or vice versa, we may be given F and we are asked for P. And the factor that we use for this one is this. Of course, you can use the formula. Okay, remember, for this case, we know the formula to be P times 1 plus I to the power n. This is the fundamental law of engineering economy. And using the same formula, you can also calculate this one. That's also the same thing. Okay? And again, in this case, P need not be at time 0. Again, it can be at time, for example, 10, the 10th year, and this is 18th year, and in between these two values, there are 8 years. If this is the case, still we use exactly the same factor table. And last time we also learned how to look at these factors from the tables given at the end of your book. Okay, these are the simplest alternatives. P given, we want to find F. Given F, we want to find P. But also, a very common cash flow is to have uniform series. And uniform series has such a form. Okay? So if we want to find a future value for which we have equal payments or equal earnings, it doesn't matter. Okay? So if the amount at each period is equal, and for example, in this case, it continues for 8 years. Okay. Again, it is not important whether this is 0 or 10. It's not important. The important thing is we do these equal payments 8 times. The number of payments is equal to 8. And look, we are finding the future value at the end of the periods, which is 8. Okay. If this is the case, we use this factor, which is A given, we want to find F with an interest rate of 10%, and the number of periods or number of payments is 8. Now, let me ask you another question, or let me give you another example. The same example, actually. Okay, this is 1, 2, up to 8. And this is A equal to this same amount. Okay, so but the thing is, let's assume that for this one we are asked the future value at time 9. Okay, not 8. In this example it was at time 8, but here now we are looking at a future value at time 9, and as you can see, at time 9 there is no cash flow. This A is done only for 8 years. So how do we find this future value? Now the thing is, if I use this factor, then I would find the future equivalent at time 8. Okay, so this I'm going to write F8, and this F8 is equal to this A, which is this value, times the factor F given A, 10%, and 8. So by this way, I find the value, the future value at time 8. But in the question, the future value at time 9 is asked. So this future value at time 9 is equal to the future value at time 8, and I need to shift this one period into the future. It means that I'm going to use this factor, P given F. Okay, so this F8, from this perspective viewpoint, F8 is the present, and this F is the future. So present given future, 10%, and I'm shifting only 1 year for one period. So it means that these two versions of the problem are not the same. They cannot be the same. In the first one, we are asking for the future value at time 8. But in the second one, we are asking for the future value at time 9. Okay? So in order to use this formula or this factor, we need to be careful. Okay? This formula, this factor given here, finds the future value exactly at the end of the period where we also have an annual cash flow. Okay, and there are other alternatives as well. Similarly, we may be given an annual amount of payment and we want to find its present value. And again, look, we have in total 8 equal payments, and if we want to find its present value, then this is the factor that we are going to use. Given A, we want to find the present value, interest rate, and the number of payments. This 8 is the number of payments again. So it's not important whether we start from year 0 or year 15. It's not important. This 8 is the number of equal payments. But again, be careful. Look, in this structure, there is no cash flow at time 0. There is no such cash flow. But if we are asked about such a question, let's assume that we have A starting from the first period, I mean time 0, and if it continues until 8, and the same amount of payment is done. And if we are asked to find this present value at time 0, this P, how shall we find it? Actually, we can divide this into two parts, saying that we have one payment of 0, which is 187.5, and nothing at 8. This is first part. This cash flow plus this cash flow starting from 1 to up to 8. When we add up these two cash flows, we find this one. Okay, so actually we can separate, we can divide these cash flows into such sub-parts, sub-components. And for this one, I know how to find the present value. It's exactly this one. So the present will be equal to this equal amount multiplied by the factor, which is P given A, 10%, and 8. And we need to add this one on top of it. What's the present value of this one? It's already at time 0. Okay, it's already in the present time. So we don't need to change anything. We just add up that one. Okay, and in total, the present value of this version is equal to this one. And as you can see, it is different from this version, because in this one, there is no cash flow at time 0. So you have to be extremely careful about this, okay? The factor that we are using here, this factor over here, is the factor for this one. And you can ask this question, but why? Why we don't have this factor over here? Why doesn't this include it? Because the economists wanted to calculate the factor corresponding to this one. There is no special reason. But actually, in fact, the reason is this. Usually, we make the payments at the end of the years. So if we are going to make payments for 8 years, we don't start paying it just now. We start paying the first amount at the end of the year. So that's why this starts at the end of the first year. And therefore, since this version is more common, this factor is calculated according to this one. And again, look at this future value. Again, you see the first payment is at the end of year 1. But still, for this future value, what you need to be careful about is, you are finding, if you use this factor, you are finding the future value at the end of, or at the period which is the last payment, okay, in the same period equal to the last payment. And you need to be careful about the number of payments. So you don't need to consider whether it is time 0 at the end of year 1, it started at the end of year 2, and etc. It's not important. For future value, the number of payments is important. And you need to know that this future value is the value at the last period. If you know this, you can calculate the future value. For present value, what you need to know is, if you use this factor over here, if you use this factor, then you will find the present value 1 period before the first payment. Okay, this present value will give you the present value 1 period earlier than the first payment. And again, you need to know the number of payments again to use in this factor. If you are careful about these two things, you can calculate the present value. And similar to this one, we have the opposites. Given a future value, how you can find the annual value. And similar to that one, look, given this future value, if you use this factor, which is A given F, okay, if you use this factor, you find the equivalent payments for 8 periods, for which the last payment will be exactly at the same time with the future amount. Okay, this is the structure. You need to memorize this structure. It is very important. And also we can do this thing, given this present value, if you want to find the annual, this is the factor that you are going to use. A given P. And as I told you in the previous lecture, this is very important, because by mistake, if you write this factor instead of this one, it's totally different. It's something else. P given A and A given P are two different things. So you need to be careful about this, because after writing this factor, you will go back to your book and look at those factor tables, and you will find this value, and this P given A value is totally different than A given P. Actually, it is one over the other. Okay? So, between future and present, it is one over the other reciprocal, but between this A and P, the formula is totally different. Okay, and also in this case, again, you need to be careful. P is given if at this time, then the first payment will occur 1 period after. And it will continue for this many periods, which is in this example 8. Okay, so I am stressing this because it's very, very important. Now, let's come to the point where we stopped last lecture. I think we stopped at this point. Actually, we were doing examples of for corresponding to these different cases, okay? And we stopped at this case. And what is this case? Given the present value, the interest rate, and the number of periods, if you want to find A, how can we find? And this version or this factor, A given P, I and N factor, is named as capital recovery factor. I told you in the previous lecture that each version of these factors have a special name, and this version is capital recovery factor. And let's consider an example which says that the present value of an amount of a lump sum money is 250,000. Consider this. You get a bank loan of 250,000 today. And we want to pay this amount back to the bank in 6 equal payments with an interest rate of 8% per year. So what will be the amount of payment? And actually, this is what the banks do. You want to buy a car, let's assume that you want to buy a car and you go to Bank Muscat or Bank Nizwa, okay? And you ask, okay, I want $250,000 to buy a car. And I want to pay this in 6 payments. How much shall I pay? You ask this question. And they do exactly this calculation and they give you this value. And what is the calculation? Again, if you like, you can use a formula, or if you like, you can use the factor. But look, the formula this time is not as simple as this 1 plus I to the power n. As you see, it is more complex, but still nothing to do. You will just plug in the values of the interest rate and the number of periods. So for example, for this example, if you want to find the annual equivalent, you will multiply this P by I, which is 0.08, okay, times 1 plus I, 0.08 to the power n, which is 6, divided by 1 plus 0.08 to the power 6 minus 1. Okay, this is how we use the formula. Or if you like, you can go to the end of your book, find the interest rate with 8%, and then find the row that corresponds to 6, and then find this table to be 0.2163. And simply multiply this value to find this. And what does it imply? It says that each period at the end of first year, you will pay $54,075. At the end of second year, you will pay the same amount, same. For 6 years, you will continue to pay this amount. And when this 6th year is over, your total loan will be repaid. And of course, you can use Excel to calculate this value. And this is the name of the function, PMT, interest rate, number of periods. And this is the borrowed amount of money. This negative is just a convention saying that whether you borrowed it or you are paying it. Okay, so you can try these in Excel, and you can try these formulas to see how they work. Now let's do a very quick and simple example. This company, Acme Steamer, purchased a new pump for 75,000. Look, this is a structure of a question that you may face in exams or quizzes. Sometimes we give you the cash flow diagram, but sometimes we give you the problem statement and ask you first sketch the cash flow diagram, then solve for the result. Okay, so in this example, there is no cash flow diagram that we provide you, but we give you the definition And from this one, you need to construct the cash flow diagram. Of course, if you don't understand the question, and if you cannot construct the cash flow diagram correctly, your final answer will be wrong. That's why it's important to understand the question, what's going on with the question, and you can construct the cash flow diagram correctly. And for this one, you need to pay attention to the problem types. So for example, at the beginning of this chapter, I told you that we have an end of period convention. So it means that if I tell you that I'm paying, for example, $50 in year 1, I am assuming that we are paying this amount at the end of year 1, okay? Not at the beginning. So this 0 and 1 actually represents the first year. This is the start of the year. This is the end of the year. But if I don't tell you that whether if it is the start of the year or end of the year, you should always assume that the payment is at the end of the year. Okay, this is very important. I don't need to tell this to you. But sometimes I will tell that the payments are at the beginning of the years. Then it's a special case. You need to construct the cash flow accordingly. But if I don't tell anything, it means that it's at the end of the year. Okay, now it says that it purchased this pump for $75,000. They borrowed the money for the pump from the bank at an interest rate of 0.5% per month, and will make a total of 24 equal monthly payments. Now, the first thing is to construct the cash flow. And it says that this is the current time, time 0, and this company borrowed the money from the bank. So when it says it borrowed the money, it means that the money is coming from bank to your pocket. It's a cash inflow. Okay, so we will assume that this amount is a cash inflow, and this amount is 75,000. And then the company will pay this money back to the bank in 24 equal monthly payments. And look, if it says like this, you cannot start the first payment directly here, because we say that the first payment always starts after 1 year. If I don't say anything in contradiction, it means that it will start at the end of the first year. So I will pay an amount here. I don't know what value it is. This is the end of first month. At the end of second month, I will pay the same amount. At the end of third month, I will pay the same amount. And I don't need to write everything, just sketch it like these 3 dots. At the end of 24th month, again, I will make this same payment. And this amount that I am going to pay, I will represent it with A, because it's a uniform payment series, equal amount, and we want to find this value. And the interest rate given per month is 0.5%. Okay, it's not important whether the periods are given in months or years. The factors inside these factor formulas, we don't have whether it's months or years. We are not converting months to years or years to months. Okay, but later on, in our next lecture, maybe we will learn the effective and nominal interest rates. And in that case, you will learn about differences between different compounding periods. But now, don't be confused. It's not important at this point whether the period is a month or a year. The factor is always the same. Okay? And what you are going to do, you cannot do this, for example, why I am saying it, 24 months means 2 years. Okay? So you cannot say that I'm going to use this factor. I want to find, let's say, A. Okay? So I will multiply this P, present value, with A given P, and then the interest rate is 0.5%. So in order to write this, you can use this 0.5%. and then the number of periods. So you cannot write 2 here. It's wrong, okay? Because you are making payment for 24 times. This value over here is the number of payments, and we are making this payment for 24 times. Okay, it's important. I know that some of you will confuse in these quizzes or exams about this, and they will assume that we always write year here, and if it is a month, then I need to convert it to month and etc. No, absolutely no. This value over here has nothing to do with the years or months and etc. It is the number of payments. Okay, and then for this example, simply we will multiply the 75,000 with this factor that you can just look at in your book, and that factor value is this much. And when you multiply, it says that this company will pay $3,322.5 each month for 24 months to the bank in order to pay the borrowed money back. Okay, so this is how we want you to solve this question. When we ask this question to you, if you just write this value without writing these, just the result, you will lose marks. Okay? Even if it is correct, you will lose marks. Because we want to see your steps. We want to see which factor you used. We want to see your calculation. We want to see this result. So this is how you're going to solve it. I hope it's clear, because even if I mention this during the lectures, even if I write this clearly at the first page of your exams, many students still don't write these steps. They just write the final result. And it is absolutely not valid. Even if it is correct, you will lose maybe more than half of the final score. The method is more important than the final result. It's important for you to understand this. Now, I'm going to illustrate a few examples, solve a few examples to illustrate different situations regarding this uniform payment series. Okay, so let's have a look at this first example over here. So we are given a uniform payment series of $100. By the way, I'm saying uniform payment series, but look, these arrows are upward, and upward means earnings. Okay, we are earning this amount. So actually it's not a payment, but it's an earning. But still, the formula and the final result will not depend on the direction of the arc here. Okay, but it's important to represent these things correctly. As I indicated several times, as I stated several times, if there is a cash inflow, the arrow must be upward. If it's a cash outflow, the arrow must be downward. Okay, it is how we use it. This is the formula, the factor formula that we need to use. And I assume that when you write this, I assume that it's over. But the thing is, still, I think some of you don't know how to look at this value in the tables. So if you don't know it, please learn it. Please review this material, these lectures, and learn it. Because it's very easy. You just go to the table with 8% interest rate, find n equal to 20, and then multiply it by 100 to find it. Okay, that's it. Now for the second one. This is the second example. In the second question, again, we have uniform payment series, and we want to find the future value. The factor, the formula that we are going to use is this one. Okay? So now let's move to this third example. Okay. Is this all? Or anything missing? So the idea is good. It should be 19. Why? Because look, in the first period, we don't have a cash flow. So compare this version to this version. They are different, right? In this one, we start from the first period, but in the second one, the first period, we don't have. So it means that there are 19 payments here. But when we use this formula, when we use this factor, we find the present value at time 1. I mean, one period before the first payment. One period before. But I want 2 periods before. How? So this value over here is this one. Let me say it's P1. But I want the value of P. How do I find P? Exactly. Look, be very careful about these things. So I wrote these examples on purpose because I know that in exams, many of you, I'm not saying some of you, I'm saying many of you will do these mistakes. So it is better to do the mistakes here. It is better to do it here to learn it. Otherwise, you will learn it in the exam, but after the exam, you got a lower score. Okay, so the idea, again, for this uniform payment series is this. We find the present value of these equal payment series, and since it starts at the end of year 2, in total there are 19 payments here, not 20. There are 19 payments. So the time is not important. The important thing is how many payments do I have? And when I use this factor over here for 19 periods, I find the present value one period before the first equal payment series. So this factor over here gives me the present value at this time. Now I need to shift it one period before. So it means that I will multiply this P1 with this factor, which shifts. By the way, we used the wrong factor over here because we are trying to find the present value given future. Okay, so this P1 is now future, and I am taking it back. So when you are taking something, when you are shifting a cash flow back in time, you need to use P given F. When you are shifting it forward in time, then you will use F given P. Okay, these are important things. So it will be P given F, 8%, and we are shifting just one period. So because of that, it is 1. And simply, you don't need to write this in such 2 stages, but you can just write it in a single stage, because I know that this P1 is this side over here. This part is P1 already, and I will just multiply it by P given F, 8%, and 1. So first find this value in the table, and find this value in the table, and multiply them all together with 100, and you will find P. That's it. Okay? Any questions? I hope it's clear. Fourth example. What is the value of this F? In this F formula, in this F given A, the important thing is how many payments do you pay? So starting from 2 to 20, you have 19 payments here, right? It's 19. And then this F given A will give you the future value at the time of the last payment, which is this one. So actually, in this one, you don't need to include anything. The formula is just this, 19. That's all. You don't need to subtract anything. You don't need to add anything. It's just this. Okay? Is it clear? So if, for example, this one there was another one like this, then instead of 19, you would use 20. But since there is no such payment, you're just having 19 payments. That's it. Okay? Let's continue with the examples. So the fifth example, look at this one. I want to find the present value here So the first payment occurs at the end of year 4 and it continues until year 23, equal amount of payments with an 8% interest rate. So what is the present value? How can I find it? Okay, so let me explain how it happens. We have these 100 payments starting from year 4 up to 23. And between 4 and 23, how many payments do we have? There are 20 payments in total. Okay, 20 payments. And when I use this factor and multiply it by 100, I calculate the present value of this one at time 3. Okay, so this will be P3. So this part over here is P3. Then I need to shift this P3 3 periods back. And in order to shift that 3 periods back, I need to use this factor. P given F, 8% and 3. Okay? So this is how we solve it. Good. Now, of course, some of you may think in this way. Is this the only way to do it? And the answer is no. You can do it in many different ways. Let me write you a different version, different solution, so that let's think if it is correct or not. I will write in this color. So I will say that this P is equal to 100 F given A, 8% and 20 multiplied by P given F, 8% and 23. So from 4 to 23, there are 20 payments. And I am finding its future value. It means that I am finding the future value at this time. This is F23 actually. So this value over here is F23. Because there are 20 payments, and when I use this factor over here, it will give me the future value which happens at the time of the last payment. And then when I have this F23, I need to shift it back to time 0, for which I will use this factor. P given F, 8% and 23. And these two are exactly equal to each other. You will obtain the same result. Just look at the tables in your book, write their values, and calculate the present value. It's the same thing. So when you have a future value, a present value, and etc., you can shift it anytime, and it will be economically equivalent. Okay? So instead of first finding the present value at time T3 and shifting back for 3 periods like this, you can shift everything to time 23 and then shift them back to time 0, and that will give you exactly the same answer. Okay, another example, look at this 6. It's just this. This part over here, it's not important for you. If it is 1000 periods before, it's not important. You just look at how many payments you have, and you look at what period we are looking for the future value. If this future value is asked with the same time of the last payment, then it is just this formula. The number of payments between 4 and 23, there are 20 payments, and we use the factor F given A. That's it. Okay? I am going to give a break after completing these 2 examples quickly. Let's have a look at example number 7. We want to find the present value. Look, after this, the number of periods, it's not important for you. For this present value, you look at how many periods these payments continue, and the present value should be 1 period before the first payment. If that's it, then you just look at, there are 19 payments from 1 to 19. There are 19 payments, and we are asked for the present value 1 period earlier than the first payment. And that's it. This is the solution. And let's have a look at number 8, the future value at time 20. How can we find? By the way, while you are thinking on this, let me give another solution for this. Again, for this P, what can I do? Of course, this is the easiest way. You don't need to find it in a different way. But I just want to show you that there may be alternative ways to find it. And one alternative way is this. This 100, I multiply it by F given A, 8% and 19. And now this value is the future value at time 19. And now I need to shift it back to present time by using P given F, 8% and 19. And these two are exactly the same. But look, in this version, we are just using a single factor. But in the second one, we are using 2 factors. So this one is easier. It's preferred one. Although they are the same, you don't need to use 2 separate factors. I mean, yes, it's correct. It's not wrong, but we don't use it. Okay? For this example, how can I find this F? So what we are doing here with this calculation, I'm finding the future value of these 19 payments at time 19. This is F19. Then I will shift it 1 period forward. And in order to shift it 1 period forward, I need to use F given P for 1 period with this interest rate. And that's it. And another method, alternative method, can be this one. So I first find the present value of these 19 payments. Okay, so P given A, which means that I find this P, and then I will shift it 20 periods forward. So I will use F given P, 8% and 20. And look, both of them are the same. And in both of them, I'm using 2 factors. So one is not preferred to the other one, exactly the same length in terms of calculation. So both will provide you exactly the same result. Okay? So now it's time to take a break for 10 minutes, and we will meet in 10 minutes.